This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, so we will be continuing with the same topic, kinematics, and we'll be reviewing some of the things that we did earlier in the previous video. So we know the difference between distance and displacement, velocity and speed from the previous videos. Also, we learned about an important fact, which is the average velocity and the instantaneous velocity. Average velocity is the velocity that you assume an object to be moving with. It's the same velocity throughout the journey. For example, this is an object moving with a velocity at 21 meters per second, and it reaches its destination with a velocity of 28 meters per second. So instead of considering velocity at different points, at this point the velocity might be different. It might be 23 meters per second. At this point it might be 24 meters per second. So instead of considering all of these velocities, what we do is we take an average of the first and the last velocity. 21 plus 28 divided by 2, which gives us 49. 49 divided by 2 would give us 24.5 meters per second. So now we assume that the box was moving with a velocity of 24.5 throughout its journey. This makes it a little inaccurate. However, for the ease that it provides, we use this method at your level. Obviously, when you go to the higher level, we do not use it anymore, so there will be a lot of surprises for you when you go to the next on the higher levels. Anyway, so this is the velocity average, and instantaneous velocities is simply velocity at every point. So this velocity is instantaneous. This velocity at this point is instantaneous. This velocity at this point is instantaneous. This at this point is instantaneous. We have seen in your speedometers something like this. And whenever you press on the accelerator, this arrow moves like this, because it's not calculating the average speed. It's calculating, for example, at one point it was 20 meters per second. At the other point it gets to 30 meters per second. So this is giving you velocity at that particular instant. At that particular instant. So this is what we learned in the previous lectures. Now we'll be taking on some questions and doing some examples. So let's see how much we have understood with the examples. So I have some questions here, and I'll be writing the data of the questions here. So let's see what our first question is. The first question says, a train increases its speed steadily from 10 meters per second to 20 meters per second in 1 minute. Okay, so a train increases its speed. For example, this is the train, like this, something like this. Okay, this is the original point. It increases its speed from 10 meters per second, so we can safely say that velocity 1 is 10 meters per second. At an increased speed to 20 meters per second till it reaches its final point in 1 minute. Now the question asks, what is its average speed during this time in meters per second? So part A, V1 plus V2 divided by 2 gives us the average speed, average velocity. So Here we have 10 plus 20 divided by 2, which gives us 30 divided by 2, which is actually 15 meters per second. Now they ask us, how far does it travel while increasing its speed? How far does it travel in this 1 minute? Now we have a formula with us that we should always remember, which says distance is equals to velocity into time. My pen is acting up, so just kindly bear with it. It would just get into its correct alignment in a while. Okay, so this is the formula. Distance is equals to velocity times time. So we have the average velocity, and we remember that this is the average velocity. So since they're asking for a distance or the displacement, so we do 15 meters per second times time. The time here is given in 1 minute, but we know that the SI unit is seconds, so we will convert this time to seconds. We know 1 minute is equals to 60 seconds, so this would mean this is 60 seconds. So you can just calculate 15 times 60 would give you 900 meters. Okay, so that is it. Okay, so this is the answer. I hope you can see this, otherwise I am writing it right here. 900 meters is the answer. It can sometimes be very crazy. Okay, now let's go to example number 2. A person is walking with a velocity of 4 meters per second for a time of 1 minute and 30 seconds. A person, this is the guy who's walking, and this is some disfigured guy, but I'm not a very good artist. So this is the person who's walking with a velocity of 20 meters per second. Let's just say 20 meters per second uniformly, which means that this is the average velocity, and we can safely use it directly in the formula. So a person is moving uniformly at a velocity of 20 meters per second for 1 minute and 30 seconds. So find out the distance traveled by the man. So for the distance, again, we can simply substitute it in the formula. T is equals to V times T. Since we have the average velocity, we do not require to calculate the average velocity again. This would be 20 into time. The time should be in seconds. So 1 minute is 60 seconds, and plus 30 seconds would be 90 seconds. So 20 into 90. The distance would be 1800 meters. So this would be another very simple example. Now let me get to a little complicated one with one more example. Let's say this is a car again, or a bike to make it more exciting. I know it's not exciting at all, but let's just say it is. So this is a bike moving at a velocity of 20 meters per second initially. Okay, moving at a velocity of 20 meters per second initially. Find out, or let's just say I don't know. Let's just say I just don't know the velocity here. Let's just say I just don't know what the velocity here. And I'm saying that I take a time of 3 minutes and 40 seconds. 3 minutes and 40 seconds, and I travel a distance of 89 meters. Part A asks me to find the average velocity. Okay, that is easy. We were using the formula before. D is equals to V times T. Since we want velocity now, so we'll just change the subject. V is equals to D over T. Distance would be 89. And time, we can convert it to seconds again. So 3 minutes is 60 times 3. This is in seconds plus 40. This becomes 220 seconds. So 89 over 220. My velocity becomes 89 over 220, which is 0.4045 meters per second. So this is my velocity average. However, the next part says, imagine if the initial velocity v1 was given to be 0.35 meters per second. Find out what was the velocity, the instantaneous velocity, when it reached the point P. Now, with the average velocity, it's telling me that the instantaneous velocity 1 is 0.35 meters per second, and we have to find the velocity 2. So simply, this is the average of these two velocities. So I will take this as x for now, since I don't know this velocity and I have to find this one out. So what I will do, I will just put in here 0.35 plus x and divided by 2. If had we known this velocity, we would have put it here and we would have found the average. But in this case, we know the average and not this velocity. So we'll take it here and 0.4045. Now simply multiply it with 2. This is basic multiplication and division. So let's just clear it here. So this is our equation for now, 0.4045. Multiply it here. This would become 0.35 plus x is equals to 0.4045 times 2. Okay, which becomes 0.35 plus x is equals to 0.809. Now x is equals to 0.809. Take this here and this would become a minus. X is equals to 0.809 minus 0.35. This becomes 0.4590 meters per second. So we can safely say that the motorbike initially started with a velocity of 0.35 meters per second, and at the final point the velocity was 0.459 meters per second. So the average velocity was 0.4045 meters per second of the bike. So remember, this is the same formula that we will be using in all the questions. Just change the subject depending on the desired information that you require, and you will be good to go. So guys, that would be it, and we'll do some more difficult examples in the videos that I will be uploading later. So for now, if you have any queries, so kindly post them down in the comments box.